Okay, Bismillahirrahmanirrahim. Good afternoon, everyone. I'm making this video to support you, okay, to prepare for the quiz. Okay, so let me share the screen. Okay, so our topic is about states and properties of matter, okay, but I divided this unit into two parts because after the quiz, we will have another part which is solution, and it's quite different. And so, because to make the topic is not that much for the quiz, so that's why I divided into two parts. Okay, so the first chapter is about gas, and these are the objective. Okay, so we are going to learn that some substances are gases, and learn about the particles model of matter for solids, liquid, and gases. Find out about the gases in air. Find out that some substances in the air cause pollution. Make a prediction about air pollution. Use results to say if the prediction was accurate. Record results and observations in drawings and tables, and draw a plot dot plot of results. We are not going to throw a dot plot of results since you do the measurement of air pollution on your own, so we cannot guarantee that all the aspect or all the variables are same. Okay, so what is matter? Matter is everything around us. Okay, everything around us is made up of matter. It is called matter. Everything, whether it is gas, it is solid or liquid, all of them are matter. Matter. Okay, so matter can be different, can be in different states. Okay, in different form. Okay. So there are three states of matter, or three phases of matter. There is solid, liquid, and gas. Okay, and I know that you have learned about this in grade 4, but let's review a little bit. Okay, so the example of solid is desk, wall, and bucket, and this is the picture of the solid particles. Okay, solid particles model. If you want to compare this, I mean, okay, the solid particles, liquid, and gas. So the solid particles, they are close to each other. The particles are close to each other, and then the distance or the spaces between each particles are same. And do they can move? Yes, they can move, but only a little bit. Okay, noted that solid particles can move, but only a little bit. And then the next one is solid. The example is liquid, I mean, the next one is liquid, and the example of liquid is water, milk, and syrup. And the other thing that can flow and you can feel, oh, it's wet. So if it is wet, it means, oh, it's liquid. Okay. And if you compare the particles of liquid into solid or gas, particles of liquid are quite close to each other, but not really close, but not that far if you compare to gas. Okay, and also because the distance or the spaces between each particles is not, it's quite close and not in a not packed in a regular pattern, so that's why they can still slide past another, so that's why the liquid can flow. And the last one is gas. The example of gas is air, oxygen, and smoke. Okay, so the particles of gas are far apart. Okay, so they are not like liquid, they're not like solid, but gas particles are far apart from each other, so they're not packed in a regular pattern, or even though in random pattern, they're far from each other. Let's continue. Okay, so these are the properties of solid particles, and these are the models. Okay, so the solid particles are packed tightly, okay, packed tightly together in a regular pattern. So you can see here, this is the pattern. It's a square, and it has the same amount of space between each particle. So the space, the width of the space is the same. In solid, the spaces between each particles are very small and not allow them to move around. To move around, it means they still can move, but only a little bit, not moving around like the particles in gas or liquid. Solid particles have a fixed position, so they cannot go slide past one another. They cannot go in all direction, okay, because they have a fixed position. And this explains why solids such as bricks have a fixed shape and cannot be squashed or compressed. Okay, cannot be squashed or compressed. I have explained this in the slide. Yeah. Okay, so how about liquid? The liquid particles are close together. Okay, they're close together, but further apart than in solid. Okay, they're quite close, but the some of them are quiet, not quiet, but a little bit further. Okay, so they are not packed in a fixed and tight patterns. So it's like they're random. The patterns are random, so they can move or vibrate faster and more freely. Okay, if we compare to solid, okay, they can move or vibrate faster. So that's why they can be flow. They can flow. Okay, it has a bigger yet different distance of space. Okay, so the distance are quite bigger. Some of them are smaller, but in different size of space. This allows the particles to slide past one another and change places, or in other way, we can say that it can flow because they can slide past one another. This explains why liquids such as water can flow and take on the shape of the container they are in. So when you pour some liquid into a glass and then pour those liquid, or yes, those water into a bottle, the shape of the liquid will adjust to the shape of the container. Okay, that's liquid. And then gas. The gas particles are far apart from each other. The particles can move freely and fast. Okay, freely and fast in all directions. It has a far or big spaces between some particles and not held together strongly. And this allows the particles to move freely and always change their position. This explains why gases such as air have no shape of their own at all, because the particles are far away from each other. Okay, and they're always moving. Okay, so the particles model, you can use this link, okay, to study about the particles model. If you raise the temperature, what will happen? If you decrease the temperature, what will happen? Okay, you can explore. This is the assignment. Okay, and the workbook page 36. You can complete the workbook page 36, and then okay, let's continue to gases. Okay, so I put some picture of gases here. Okay, so there are many type of gases actually, not only oxygen, not only water vapor, not only air, but there are many types of gases actually. Okay, since we cannot see the gases, so yes, but yes, there are many types of gases. Okay, so what is gas? Gas is a part of a matter. Okay, the state one of the state of matter is a gas. Okay, and this gas has a mass and takes up space. It's like the solid and liquid as well, but the differences is that the gas has the particles of the gas is far apart from each other. It is not packed in a certain pattern. Okay, and they can move in all direction, and the spaces between particles are quite big. Is gas a part of matter? Yes, it's part of matter. How do you prove that gas is matter? So we know that matter, it has a mass and takes up space. So when you blow up a balloon, okay, when you blow up the balloon and then you throw it somewhere, okay, from the high place, I'm sure that the balloon will fall down. Why? Because it has mass and it takes up space. If how do you prove that it takes up space? The balloon inflate, right? When the balloon inflate, it means, oh, it takes up space inside of the balloon. How does it have a mass or weight? Yes, of course. Does it take space of have volume? Like I told you, yes. Can you see or feel or smell or taste gases? Yes, for some cases, but most gases are invisible, so we cannot see through the gases. Okay, we cannot not we can see through the gases because it's transparent, and sometimes we cannot feel or taste. Okay, because most gases are tasteless, and they have no odor, some of them, but some other they have. Okay, the next. Okay, so this activity in learner's book page 57. Okay, we have ever done this, and okay, so this proof, this simulation said, the simulation proof that unlike solid, gas can be squashed. Okay, so the gas, because it has a bigger space between the particles, we can compress the gas, so the space between each particles will be closer, so that's why the gas can be squashed or compressed. And then gases in the atmosphere or air. Okay, so actually there are many type of gases in the atmosphere. I will not ask you to memorize all of them, just some of the gas that is most important for our life, such as oxygen, carbon dioxide, water vapor, and nitrogen. Okay, and you might be familiar with hydrogen as well. Okay, so air is a mixture of different gases, and the first one, okay, the most important one for the human is the oxygen, because we breathe in oxygen. We need oxygen to do the respiration. Okay, so we breathe in the oxygen, and then we breathe out carbon dioxide along with the water vapor, and then yes, water vapor also breathe out also the gas that we breathe out. How do we prove that we produce or we release water vapor as well? You can breathe in, you can breathe out on a mirror, and yes, I'm sure you have ever done this on a mirror or on a glass, and then you can you can feel that, oh, on a glass there are some drops, water drops. So that's water vapor, but it it experiences condensation, so that's why this water vapor becomes water drops on a surface. Atmosphere is the layers of air that surrounds the earth. Okay, so this is the atmosphere. Okay, so there are many, not many. Okay, there are some layers of the atmosphere: troposphere, stratosphere, mesosphere, thermosphere, and exosphere. But I do not ask you to memorize this. Okay, this is just supplementary topic. Okay, I have written here. Okay, so this is just supplementary topics. What you have to notice that it's also stated in your book that nitrogen is the biggest part of the atmosphere. Okay, so the biggest composition of our atmosphere or gases in the atmosphere is the nitrogen. It composes about 78 to 79% of all gases. Okay, and oxygen compose 21% of the atmosphere. Okay, and the other gases, the other 1% is can be carbon dioxide, hydrogen, helium, and the other gases. Okay, and carbon dioxide makes up 0.04% of the gases in the atmosphere. Okay, the other mostly argon, 0.96%. This is also supplementary topic. This data just to show you that, oh, nitrogen is really the most part, I mean the most gases, the most abundant gas in the atmosphere. Okay, it's nitrogen. Okay, so you can do workbook page 37 to 38 to have practice. And then let's continue to air pollution. Okay, wait. So these are the pictures, the images that I put here. The first one is the volcano, the ash. It can pollute the air. And then the second one, this is the gases, greenhouse gases. Okay, and these also the smoke from the factories. This is the smoke from the vehicles, and these are the dust. Okay, so all of these are air pollution. Okay, you can watch the video about air pollution, and wait, this is the summary of that video. Okay, so the causes of air pollution can be volcano eruption, dust storms, usually in the desert. Okay, wildfire, smokes, okay, from the factories, power plants, vehicle, chemical, airplanes, break-in, and methane. And fossil fuels also causes air pollution. What is the effect of air pollution? Okay, it can cause some health problems, okay, such as headache, dizziness, especially for us, the human, dizziness, organs irritation, lungs disease, or respiratory disease. It can be damaging and harmful for the plants, and it also can cause breathing problems in the animals and skin infections and the other disease, especially respiratory disease. And it can cause also ozone layer decay, greenhouse effect, definitely, and global warming. What is the solution? Oh, we have to use it is suggested to use public transport or bicycle or by walking, and then switch off appliances when it is not necessary, and recycle and reuse the things, okay, that can be recycled and can be reused, and plant trees. Okay, so measuring air pollution. Okay, for this one, I have ever asked you to do it in group work to decide in which places you are going to put the paper. Okay, the paper, so you can and leave it for a few days so you can see how dirt or not how dirt. Okay, which one is more polluted? Okay, inside or outside? Okay, so this is the result. Okay, so uh if this is the result or no, it it's supposed to be outside, okay, and this one's supposed to be inside. I will fix the PowerPoint after this. Okay, so this is inside, okay, and this is outside. Okay, from this is switch, I accidentally switch. Okay, and you can see that outside, the paper outside, it has more dirt on it. Okay, so it means that outside is more polluted rather than inside. For the inside one, it's quite clear, quite clean. So inside of the house is cleaner rather than outside. Okay, so which one has more pollution? It's outside, obviously. Why? Because outside, there are many air pollution outside, right? Many smoke, and then dirt, dust, many air pollution, many dirt is being brought by the wind or by the air. In your opinion, what type of air pollution catched by the paper or the tape or the paper? Yeah, this one. I think dust, which place has the least pollution, it's inside. Give your opinion why it is the least one. Because inside, it's mostly closed, yeah. Okay, in a room, it is closed, so it has least pollution. Okay, let's go on to the properties of the water. Okay, so we are going to investigate the properties of water, learn that most water on Earth has dissolved substances in it, measure temperature, identify safety risks in an investigation and work safely, record measurement in a table, draw line graph results, okay, find information to answer a scientific question. Okay, so actually we have did this one, and that's a good. Why water is important? Of course it's important because we cannot live without water. We can live without food maybe for a week, but without water, we can only live maybe maximum 3 or 4 days. So, why we need water? Because water, liquid runs through our blood, vein, and then we need water to, what is it? To dissolve some substances in our body. Okay, so water is also cleaning our body. Why do we need water? Okay, so that's the answer I've just told you. What is the form of most water? Okay, the form of the water, there are three forms of water: water vapor, water, and ice cube. Okay, and the form of most water on Earth is the water itself, not as the ice cube, not as the water vapor. Okay, so based on your book, the properties of water, the first one is water exists in three different states: solid, liquid, and gases and gas. Okay, and water changes states when it is heated or cold because water particles expand. Okay, it is getting the arrangement of the particles is getting bigger or smaller, and then substances dissolve in the water. How do you know? Dissolve mean larut, yeah. So when you put when you add maybe three spoon of salt, and then you stir it in the water, it will dissolve. It's like disappear, but it's not, it's actually united with the water, some kind of that. Okay, so the next one is temperature and thermometer. Okay, so these are many types of thermometer. And okay, temperature is a physical quantity that expresses hot or cold. Okay, let's say it is how cold or how hot is an object. That's temperature. Thermometer is the instrument used to measure temperature of an object. So we need nowadays we really need this temperature because it indicates the healthiness of the people, right? Okay, so this is thermogun. I am sure you are familiar with this one. And this one, the body thermometer, you've got on your own, I mean, each of you. And then this is the wall thermometer. And then this is also a body thermometer. And for this one, it's a room thermometer. And this one is the laboratory thermometer or the glass thermometer. We have ever used this one, right? Okay, so the next one, because one of the properties of the water is that it can change its states, okay, and these are the process of changing the state of the water, which is melting and boiling. Actually, the process are not only two, there are many of them, but okay, since these are the first two processes, melting point of ice. What is melting point of ice? It is the melting point or something that is end with point. It refers in this topic, it refers to the temperature. Yeah, so the temperature in which the ice turns into water. Okay, so melting point, melting is meleleh. It means that solid to liquid or ice turns into water. Okay, and our activity, we have ever done this also. Okay, I have another explanation video about melting point and boiling point. You can rewatch that video if you need more explanation. Collecting data. Okay, we have collected the data. We try to melt the ice and then we measure the temperature. Okay, we measure the time, okay, of melting ice. Okay, and boiling point of water. Okay, the temperature in which the water turns into water vapor or steam or heated water vapor. Okay, so it refers to the temperature, but the changes of state is water it turns into water vapor. Okay, the activity is same as melting point. We collecting the data. We collect the data. We collect the time and temperature of boiling point. Okay, boiling of water. Okay, I will change this into boiling water. Okay, and then drawing graph. Yes, after we collect the data, we draw the graph. Okay, so it's a further explanation about melting and boiling. All substances melt and boil. Different substances take different times to melt or boil because it takes different amounts of heat for them to change state. Okay, so all substances, even the metal, okay, it can melt, it can boil, but the temperature, the heat requires to melt and to boil those metals are very, very high. Okay, different substances. Okay, if we compare, for example, the nitrogen and the water, okay, it takes different substances take different times, or it takes, yes, different times to melt or boil because it takes different amounts of heat for them to change state. Okay, for the water, it's easy to melt and to boil. It doesn't really require much heat, but for other substances, they need much of heat. I mean, much heat. Okay, so what is melting? This is when it changes from a solid to a liquid, and the melting point of ice generally is 0 degrees Celsius. It's generally melting point of ice that comes from a pure water, comes from pure water. What about boiling? Boiling is when it changes from a liquid to a gas, okay, from liquid to gas, and the boiling point of water, pure water in 1 atmosphere at 100 degrees centigrade. Okay, so these are how we set our instrument, okay, how we set the materials, and this is the melting point investigation format report. I have shared this, okay, you can access this one. Okay, wait. Okay, so this is the result I take from one of I think this is from 5 Oxford or 5 Cambridge. Okay, so uh this is the graph of the table. This is the data that we have collected, and when we interpret the table into a graph, it will be like this. And this part is the melting point, okay, because it stays, if you look at this graph, okay, so this part, the temperature is increasing from -4 into 0, okay, but in 0 degrees Celsius or 0 degrees centigrade, it stayed for some minutes, and then it raised again. Okay, why it stays? Because the heat is used to melt the ice, okay. So in this part, it is solid, okay. In this part, it is the melting process, and in this part, it's a liquid, okay. So that's how does it work. Okay, how about boiling point? Okay, this is the boiling point uh, instrument setting. Okay, for the boiling point, so this is the boiling point. Okay, the data is not really as good as the melting one, but let's make it clear that this is the boiling point. Okay, so the temperature is rising, and then in certain minutes, the temperature stays still for we cannot reach 100 degrees Celsius because we cannot guarantee that we use the pure water, or the air pressure. The air pressure in our place is less than 1 atmosphere. So that's why it has reached its boiling point before 100 degrees Celsius. But mostly, I just want to show you this is the boiling point. This is the point where the liquid turns into gas. Okay, and this one, particles arrangement expand and contract. So water expands. So when the particles of the water, okay, sometimes they get closer to each other, we call this as contract, and then when they get further from each other, we call this as expand, okay. When they contract and when they contract and when they expand, it means it depends on the heat, on the temperature. When the temperature is rising, it means that the water particles expand. But when the temperature is decreasing, so it means that the water particles contracts or getting close to each other. You can read this one. It's in your learner's book. Okay, so okay, this is our making ice cream activity. We freeze the liquid, okay. So actually we need to measure the temperature before and after the shaking process, before and after you freeze the milk. But since we did this in our own, so I cannot provide you with the thermometer because your body thermometer cannot measure this one, okay. But at least you know that oh, the water freeze, and you freeze without using any device that is connected to electricity, okay. Okay, this is the goal, the materials, you can do it on your own for fun. Okay, this is the explanation. So why we have to add salt? So the salt added to the ice lowers the melting point of ice, so it won't melt in 0 degree, okay. Okay, just like it does when we add salt to roads in the winter in order for the ice to melt. However, it has to absorb heat from its surroundings, like the ice cream in the bag. So the heat that is contained inside of the milk is absorbed or is taken away by the salt. Okay, so that's why we need salt. Okay, the last topic is about evaporation and condensation. So we learn about and investigate evaporation and condensation. Use the particles model to explain evaporation and condensation, and use scientific knowledge to make a prediction. Use results to say if predictions are correct. Suggest a way to improve an investigation. Identify variables in a pair task investigation, and make a drawing of the observations. Okay, simply, evaporation is about the water which turns into water vapor because it is exposed to heat. Okay, it's simply. Or in a pattern, we write like this: the water plus heat or energy or warmth condition, it becomes water vapor. Okay, or the liquid when it is exposed to heat, energy, or warmth, it becomes gas. But evaporation, what is the differences between evaporation and boiling? So boiling has to reach certain temperature. For example, like the boiling point of water is 100 degrees Celsius. But it happens faster rather than evaporation. But for evaporation, it doesn't need certain temperature. I mean, it doesn't have to reach 100 degrees Celsius to evaporation to be occur. Okay, so evaporation can happen just when you expose the water when the water is exposed to heat or warmth. Okay. Okay, then this is the explanation. So water particles gain heat energy. Okay, and it causes the particles to move faster and further apart. So that's why when they move faster and when they move further apart, it means that they're going to change its state. Okay, so the arrangement of the particles are getting looser. I mean, getting not compact, it less dense. And the particles which move so far apart escape from the surface of the water to its surrounding. Okay, so these particles, those are water vapor because they escape because they gain heat and they move a lot, they move faster, so that's why they become water vapor. Okay, this is in page 72, the activity. It's mistyping. Yeah, later I will fix this. Okay, what about condensation? So simply, condensation is the reverse of evaporation. If evaporation is the process of water becomes water vapor, condensation is the process of water vapor becomes water or water drop. Okay, I put the sign minus or subtraction here because the heat energy contained in the water vapor is taken away when they becomes water drop. Okay, so yes, shortly it is a gas. Okay, and when the heat energy is taken away from the gas, it becomes liquid because the arrangement of the particles is getting closer to each other. Okay, how do you prove condensation does exist? I'm sure that you have ever done this. You might be wondering why there are water drops on the surface of the glass. It's not because the glass has holes on it. Okay, it's because the water vapor, okay, in the surrounding, I mean in the air around the glass, the temperature of those water vapor is lowered and the heat from this water vapor is taken away. So that's why they becomes water drop on the surface of the glass. If you ask me why the water drops exist on the surface of the glass, why it doesn't exist on the air, because the surface of the water glass which is getting cold, it's not the air, but it's the water, I mean the surface which is getting colder. Okay, so it happens because the warm air which composed of water vapor touches the cooler surface. I mean, it causes the gas particles to lose energy. and the particles' movement start to slow down and change its state into the denser state. If the surface is cold enough, the water vapor gas changes to drop of liquid water. Okay, the activity is on Learnbook page 73 to 74, and you can complete the workbook page 39 to 42 for your practice, and you can have a practice on this link. Okay, link of quizzes. I mean, uh, I have I have edited some of the questions, so I hope that will help you to answer the questions. Okay, so okay, that's all for the brief explanation of this unit. Okay, I hope this video will help you. Thank you very much, everyone. Good luck for the quiz. Wassalamualaikum warahmatullahi wabarakatuh.